So the agenda for today, we'll do a really quick intro on civil objects. I know many of the attendees here have seen them before, so we'll do enough just so people who haven't seen it know what they're about. We'll then look at importing 12D ASCII for those objects. We'll do a simple import first, then we'll look at the XREFs and data shortcuts, which we call DREFs, and how they interact with the 12D ASCII. And that's really what it's all about for workflows. Then we leave a bit of time for questions and do a quick summary. So we've shown this to a few people, well, quite a few people in fact, and the questions that they've always asked us is what's in it for the 12D guy, the CAD guy, and management. So we'll address those questions as the presentation continues. So the history of all this. Now let me just bring up one more screen here for myself. I can get an audience view here somewhere. Okay, I now have a preview so I can see if I'm going too fast or too slow. So the history of all this is that Autodesk built a GenIO importer quite a few years ago. So this was for the MX faithful guys in the UK. That worked out quite nicely. They then purchased Dynamite. And anybody who's used Dynamite will know that that imports 12D ASCII files. So we put the pressure on them and asked them why not combine the two and build a 12D importer, because they had the functionality in Civil and they had the know-how of 12D. So they've gone and they've done that for us. Now that in itself is quite a coup, because the guys in the US don't normally build functionality specifically for the ANZ market. So having that in itself was something that we're pretty excited about, and that's why we want to get as much feedback as possible. Because they've basically done the work for us, I see it as up to us to let them know what needs to get enhanced and have them do continue the good work, I suppose. Now, the purpose of this 12D importer is basically you design in 12D and you draft in Civil. And you use 12D ASCII instead of DXF to get from one to the other. We'll go through the pros and cons of the 12D ASCII method, and that's where we want to get your honest feedback on how realistic it is and how practical and what can improve, etc. Now we'll just do some very, very quick polls before we kick into it. We won't go overboard in these. We've been told in the past not to do too many. But one thing we'd like to know is how many people are watching at your screen? Because we know that many of the guys have lunch and gather around and do some bits and pieces. So we've got quite a few of individuals, lots of 2 to 5s, 10% of those, and a couple of 6 to 10s, which is cool. So let me close that poll. The next one we're after, and this is relevant later on in the session, we want to know, do you use annotation scaling? So it came out a couple of years ago. It's something which Civil has been doing for years, and we're just curious on who actually uses it and who doesn't use it. Okay, so it's kind of 60% yes and 40% no, which is interesting. And the last one we've got is, do you use the sheet set manager? And again, that's been out for ages and ages. I think when it first came out, nobody was using it, but as time kind of moved on, people got their heads around it more and more. So it's more or less 50-50, actually maybe 60-40, no to yes. So let me close this. I'll actually share the results of that one so you can see. So you should now see on your screen the results of the Sheet Set Manager poll. And again, that's relevant for one of the things we're going to discuss here, because the Sheet Set Manager actually came from Civil originally. So okay, that's cool. Let's just hide that and switch back to my screen. So we'll look at that information, and we'll now just kick into the real presentation. So let's look at some Civil objects extremely quickly, and then we will look at a 12D importer. So those of you who've seen this, just be slightly patient, it won't take long. What we've got here, for the guys who haven't seen Civil before, this is a surface object. So we've got the triangles, or the tin network in 12D language, shown up with elevations color-coded as different colors. So there's a table here. Excuse me. There's a table here which basically explains what each color represents, which elevation range. And the example that I always show to kind of illustrate how the software works is when you go to the surface properties, you go to analysis and you change the number of ranges. I'll make it 2. I can change these colors. Now I'm doing this extremely quickly because I don't want to waste time on it. So I've just changed the number of ranges and the color specifics. So what you'll see is that the triangle is updated, and so has the table. And that's what I see as a good illustration of how the software works, because everything that you create, you can move around and the labels and tables update for you. Of course, you can pick this surface object and show it as contours, which is what you do 95% of the time anyway. So let's just put in 1 meter contours. One of the lesser known things about the software is that with the contours, you can also do analysis. So when you go to surface properties, under analysis here, I'll slow down on this screen slightly. So you should now see the surface properties analysis tab with the contours option selected. If I pick 2 ranges, you will see here we have range 1 and range 2 with different colors. So when I press apply, the model space shows 2 different contour analysis. So you can do the same thing with the standard contours as well. And there's all kinds of nice labels you can do here. So I'm just going to select multiple contour labels. Now, as I move around the screen, the contours that I cross get labeled. Now I'm going to zoom in so you can see what's happened here. So contour labels have shown up. If I pick this, the line actually still exists in the background, and when I move it, I haven't erased the contours, I've only masked them. So you actually preserve the geometry. There's a few other ones which I'll look at very, very quickly. A popular one is spot elevations. So you basically pick an elevation, and wherever you pick, that triangle gets labeled. You can move these around and the labels update, which is a nice little design tool. Instead of doing that, you also have the option to right-click and select Inquiry, which I'm hovering over right now. That inquiry lets you look at information without displaying labels. So you don't have to have the labels on the screen if you don't want. There's all kinds of variations on this. I'm going to skip them because I know that many of the attendees have seen them before. So let's just show horizontal geometry very quickly. With the horizontal geometry, you've got, again, a bunch of labels. So you can pick it, right-click. You've got, let's just say, 10-meter changes. We can do, say, a highway version, where it shows tangent points and spiral to curve transitions. You've got all kinds of variations on that. We asked about annotation scaling. The annotation scaling was on Civil before it came to AutoCAD, and it's actually quite a bit easier to use. You don't have to set up all the various scales. It just does it for you automatically. So I've heard some people say that they find the AutoCAD one a bit hard work. With this one, it happens out of the box. So another popular label here is the station offset one. So you pick a property here, and it tells you the chainage offset from that property and all the other information that you want to see as well. Now we configure these labels to do all kinds of specific things. So again, we won't go into it now. We'll show some of it later on, but we can do many variations on that. What I've got over here, I'll just stop panning so you can see it properly. That's a set-out table for a piece of horizontal geometry. So you can see that in this case, line 1 goes from chainage 0 to chainage 162.287. So let me just move that geometry slightly. So you can see, now again, I'm going too fast for your screens probably, but what you'll see on the table is that the chainage now shows 0 to 211. So as you move one element, the tables update and everything. Same goes for the profiles, our long sections. Let me just get some more screen space here for myself. You can select, right-click, and edit labels, and you can do all kinds of groovy things. Let's just import a label set with the lines on the bottom, which is a popular one. That's kind of a more standard Aussie label set. You got a few variations on that. One of them, which is interesting, is lines on the bottom with design information. So the contents of these green boxes are not plotted. They're on the def points layer, but as you're looking at the drawing in CAD, you can get more information without having to go and inquire it. Again, some guys like that, other guys don't, so it's in the default country kit, so you can use it or ignore it. But the point is that the objects themselves are quite interactive. There's another drawing I've got here, which has got some other examples, which we'll very quickly look at. In this case, we've done some cross-section plotting, which is one of the newer features to come out to Aussie standards. We'll show an example of those in a second. We've also got some pipe objects, so you can see the pipes can get produced in Aussie-style long sections as well. Again, there's all kinds of variations on these. We got a lot of help on this from the guys in New Zealand. They've been using it for a bit longer than we had, and they had been through many of the teething issues. So they helped us to produce basically the proper-looking long sections. These do clash detections and a bunch of other things as well. And the last thing I'll show is some cross-section sheets. So it uses the sheet set manager to produce these. And again, we will dig into it slightly. We won't have time to go into it in much detail, but if you want to see it in detail, let us know, and we'll be more than happy to do it. An interesting point is that the section on the top right is obviously wider than the rest of them, so it's got enough intelligence to fit them into the sheet without having overlaps, which is quite a nice little feature. Now, again, let me put that away and get into the interesting part for the 12D perspective. So I'm going to start a brand new drawing, and I'm going to import some 12D geometry. So we'll show you where to download this from at the end of the session, but it's basically on the subscription center. And when you download it, you go to your toolbox, which I've highlighted here. You go to Subscription Extension Manager, and you'll see 12D Data Extension. So I double-click to import 12D data, and I get this dialog box here. So let me open a file first of all. So we'll click on, this is a simple little file called temp_road.12da. This is just a surface, a simple road, and some strings. You'll notice that as I highlight the various models in 12D language, I see the strings associated with those. What you can also do is right-click here and select all models and strings, which is what I normally do to start with. There's a second tab which gives you control over how these things come into the software. So we'll say that when alignments come in, we want to see them as design with line weight. Again, as you use the software more, these become more useful for you. When surfaces come in, I like to see contours and triangles, because basically the triangles tell everything, etc., etc. So you can go through these. If you want to get really intricate, you've got a table where you can match specific styles to specific model names. So that's quite like Dynamite if anyone's used it. So you can get into that level of detail if you want. Let's just ignore all that for the time being. We'll press Import, and it runs through the motions. So 1,000 strings have come in. You press OK and close. And what you see now on the screen is some triangulation. So there's two surfaces. There's a road surface and the existing ground, as well as the profile view. So you don't need all these. It actually imports the AutoCAD triangles as well, which you don't necessarily need. So I'm just going to erase them because they clutter up what's behind everything. So what we've got here are our surface models. So if I click on my natural surface here, this is now a perfectly standard civil surface object. So all the things you normally do in civil, you can now do here. So if I go to 2-meter contours, I can select, go to Add Labels, Contour Multiple, and start putting my labels around here. If I change my scale, they'll become more visible. Again, I can pick this and do, I won't go through all of it, but you can do all the standard labels that you would do. Let's do one more. So spot elevations. So perfectly normal civil surface. This one here, exact same. So you have the option to go in here and show this at a higher contour interval. So we'll show, let's say, 0.1 meters. It's a road design. You can see exactly what's happening here. Now we'll do more with this file later on. This is just to show a simple import process first of all. So that's pretty good. The long section has also come in. Now the way it's been exported, it had the design surface but not the natural surface on the alignment. So I can press my alignment here. Now let me just slow down so your screens catch up. So what I've just done is I've highlighted the horizontal geometry. I press Surface Profile in the ribbon, and I say I want to add my natural surface. And when I press OK, that gets added to my information. So when I go back to my view, I can see my dotted green line for natural surface. So again, for labels, you select the design surface or the design line, and you pick which labels you want to see. I'm doing it quite quickly here. We can automate this by specifying on the import which labels to put onto which strings as well, and saving that file for future reference. What you can also do is specify which bands you want to see. So Civil refers to bands as the design levels, existing levels, chainage that you see on the bottom. So we've got a bunch of options for this. As you see, there's multiple surfaces, there's horizontal and vertical geometry, there's all kinds of things you can add there. Let's go for, let's look at this one, geometry details and super elevation. So you can pick one which is close to what you want and then remove the bits you don't want. So for example, we don't have super in this road, so we remove it. We must now tell it which surface is which. So the design is P1 and natural surface is P2. So you press through these, and that will show up with all the behavior you'd expect with labels and staggering and stuff. Now this business of staggering the vertical lines coming down to label everything, that wasn't in the software in the past because it's not done in the US. It took a long time to come in, but when they finally got it in, it's done a good job, because if you change your scale to 1:500, for example, the staggering isn't necessary, so it doesn't happen. So as you produce this drawing at different scales, you're not restricted to having staggers on the whole time. It's quite intelligent in terms of dynamically changing for these things. So some of the other nice functions, you can select this, and it's at an exaggeration at the moment of 1:5, I think. So you pick it, use the AutoCAD copy command, and put it next door. And on the next version, you can select, go to your profile view properties, and change it from 10 times exaggeration. I'll just change it to 1:1. I'm just slowing down so your screens catch up with this. So I picked 1 times exaggeration. I press OK, and you can see now we get the true view of the profile as opposed to the exaggerated. Now one of the challenges in CAD is when you have vertical exaggeration turned on, it becomes difficult to label heights and everything else. That's actually in the software as well. You select here, and you have add view labels, station elevation, and depth. So if you go for station elevation, you basically pick the point you want, and it just puts a label here. So it tells you the chainage elevation. Simple enough. If you go for depth, you basically pick 2 points that are of interest, and it labels them for you. So it's doing a standard dimension, only it's taking into account the vertical exaggeration you've specified. So again, it's a nice tool to save time on the annotation process. So that's the basics of a simple import. The software does take in more than just simple alignments and roads. So let's just go through a few more of these. I'll close this drawing. And I've got some saved files here. So let's look at some survey. I don't know how many people are doing survey in this group, so I'll do it quite quickly just so you're aware of it. So there's all kinds of nice features in the software for point styles and graphics and labels and everything else. So what I want to do is basically take in the points file from a 12D survey. So again, I go back to my toolbox, double click here, and the file I open this time is points survey. This is quite a big survey. It's got a bunch of points and a bunch of strings on it. Let's just click on the vegetation points, which are the trees and everything else. Let's select all of these and import them. So the software runs through that motion. It's reading in the strings now. And what it's going to do is put them on the correct layers and the correct symbols and everything else because we've set that up in the drawing. So I'll zoom in here and I'll pause when I get in close. So you will see various points have come in. So if your screens catch up now, you will see that there is point number, elevation, and the strings and names and everything else. And other points are showing up with a tree symbol because they have that symbol set up. So you can go and enable the symbology easily to do that. And again, we've done webcasts on that in the past. We're happy to go into more details. I want to just make everyone aware it can be done, and we'll do more on it some other time. There is also one last thing to show. You can add tables. So we select a bunch of points here. And you pick the table style. You press OK. So again, it's the standard stuff that you always do, but it's quite tidy and dynamic as well. So as the points change, the tables will update. So if this is of interest, just make a note of it. Leave us know at the end, and we'll arrange to do a separate session on it. So again, I'm going to close that one. So I want to make sure I get through all the stuff we've got ready here. Now this one is quite interesting. This is where the sheet set manager comes in. So I forget which release it was when the sheet set manager came out, but it was definitely part of this process originally. It was then taken into AutoCAD afterwards. So I've got a surface model set up here, and if I go to my tool space and import, and if I go to my sheets, let me just check I got my correct folder, sheets, yeah. I'll begin my road. So what this is a design string. So you can see it has a profile on the top right, and it has the horizontal geometry on top of the surface now. So we can do all kinds of things with this, including create the actual production sheets. Let's just first of all look at the horizontal geometry. I'm going to use my zoom command to keep your screens more up to date. So I select this, I right click and go to my edit labels, and I will tell it to use, we'll say 15 meter chain edges with tangent points. So that shows up quite easily. The classic case where there's an interesting piece of geometry somewhere off the side and you want to label the chain edge offset, you can do that by saying add labels, chain edge offset, pick the relevant point, and that will get labeled for you. Now you can do some nice things with this. When we actually plot this, you will see that the text always stays vertical for these labels. Let's just do a second one at a more sloped part of the geometry. So we'll do one here as well, and select add labels, station offset fixed point, and pick that one. Again, I'll drag it across here. So that's the station offsets. There's some nice things here that you mightn't be aware of, where if some of these labels were crossing over other geometry, if you hold the control button, you can pick one of them, right click and select flip, and it puts it across to the other side. It's a simple little thing, but it can be very useful. You can also hold control and drag one label and do all kinds of groovy things with the actual annotation of it. So There's nice tools to make the thing plotting well. We just do some very quick contour labels here. So again, add labels, contour multiple. And again, something that people aren't always aware of is after you've put these labels in, if you decide you only want to label the major contours and not the minor, you select the label, you go to your AutoCAD properties, and when your screens catch up here, I'm hovering the mouse over the option for display minor contour labels, true or false. So we'll say make that false, and just the majors show up. So there's more, but that's enough to show you the concept of the horizontal geometry. In terms of the vertical geometry, let me just select this and add the natural surface to it, because again, that wasn't part of the export. So we can do the same thing that we had previously, where we can put all kinds of labels all over this. I'll skip most of that because you've seen it already. I'll just go and tell the software which surface is which. So if I go to my bands, I will tell it that my design is P1 and my natural is P2. So we can do splitting profile views, which I've got a better example because this one doesn't vary in elevation too much. I've got another example where the elevation varies quite a lot, so we can show how the software is quite clever in making the splits for us. But what we're going to do next, let me just do a save as, so I keep my original file slightly clean. So I'll call this webcast. I'll now go and create the sheets. So if I go to my Output tab, there's a Create View Frames button. So when you press this, you pick your horizontal geometry. There's a couple of options here that are pretty important. So you tell the software whether it's plan and profile, which it usually is, plan only or profile only for drainage. So we'll do plan and profile. And then it asks you questions about the sheet set manager and the naming conventions and stuff, which we'll just take defaults for the time being. And it creates the view frames here. Actually, there's one very important thing which I skipped just there. On the sheets, you press this button I'm hovering over right now, which you should see. And in there, you will see A and Z 1:500 for A1, 1:200, same for A2 and A3. So that's where you pick your sheet size. So I picked A1 1:500. If you don't see these, press that browse button and you browse to the plant production and you'll see the A and Z options here. So again, we're happy to do more details on any of these. This is just to show the concept. So we press OK to all this. We've made our sheets. I save my drawing. Then you press Create Sheets. Now, in this case, there's only 2 sheets. So I'm going to say put everything into the tabs of my current drawing, which is the bottom option. You can do individual drawings, which I'll do next. What I'll also do is tell the software to create the north arrow. So it puts that arrow and orientates it correctly for you as well. So here's where it makes the sheet set. I'm going to call this sheet set Webcast 12D. You could add to existing sheet sets as well, or if you're into Vault, you can add them into Vault as well. You go on next. Now, for the profile views, you can do all kinds of clever things here. Let's do a simple one first of all. I'm going to select and say take all settings from this one here. When I press Create Sheets, it warns me it's going to save my drawing. That's okay. I click on a point up here, and it now goes and creates these 2 drawing sheets for me. And you can see it's done the Sheet Set Manager as well. So it takes away all the grunt work in doing that, automates it for you. You now go to your tabs. You see Sheet 1 here. Let me just close the Sheet Set view. And all those labels, everything shows up as expected. You can, at this stage, you can come in here and double-click. You can select that profile and do whatever you want with the labels. So let's select for this one. Let's put in the default view, which puts labels all over here. You can pick these and stretch them around and make them look exactly as you want. So if you zoom in here, you've got a lot of control in terms of making the thing not have text overlapping. So that takes care of all this. If you look at the top right, so I'm trying to keep my zooming to a minimum to keep your screens refreshing. On the top right here, I've just zoomed in. You can see the north arrow has been placed and orientated for us automatically. So it's doing quite a complete job. And so this is the simple example where we put everything into the current drawing, which you don't have to do. So the next one we'll do a more interesting version. So again, we select here, and we go to edit labels. This time we put in lines on the bottom, which puts in that standard view as well. So that's a quick kind of a snapshot of how the sheets work. You will notice it's a small thing, but often quite important. This offset label here that I'm holding the mouse over now, that's always pointing up the screen, so the text is always legible. You can do the same thing with the chainage labels if you want, but usually you want those to follow the road direction. But you have this level of control with the software once the templates have been set up correctly, which we've become quite good at because we've done so many of them. So if you want anything else on that, let us know. Let's just close this example. And I'm going to open up another one. So this is Sheets 2. So this one is a highway reconstruction. So it's a different type of an example where there's more sheets involved in it. So you can see it's basically a survey of a road going south to north. So this is just a survey. Again, I go to my 12D import and I open, let's go back one step, click on Sheets 2 and take in our design. Now we do have all the offset strings and everything else. In this case, all I care about is my centerline string. So this was done for, looks like the RTA, because it's an MX MC01. So you press import, and what that does is brings in the geometry for us. So you can see, once again, it's done the profile view, or the long section view on the top right. And when I zoom in to my survey, I can now see my string is up the guts of my terrain model, which is exactly where it should be. So let's just do a few examples here. Let's go and add the natural surface to that view. Now in this case, we're going to do some variations. So first of all, I'm going to do a save as, so I keep my original file clean once again. So I'll call this webcast sheets demo. So we go back to our output tab and we select create view frames. So we will stick with A1 at 1:500, and we will basically click default settings for all these. They're pretty simple, and we press create view frames, and this shows up here. Now a function I didn't show you earlier, which I should have, was you can select these view frames and slide them along the alignment. So if your screen's web connection is fast enough, you will see that as I travel along the curve here, the view frame kind of orientates itself automatically. You can also just move it with standard XY offsets. So you can place these quite carefully. Again, I'm just doing a sample here, so I'm just charging through them. Something else you'll notice is that the sheet number here, when it catches up on the screens, it's sheet with 4 hashes. It doesn't have a number yet. That's because we haven't created any information yet. When we do it, it will know what the number is. It's sheet 4, it's sheet 5, and it will then populate it. So if we erase them now, it won't destroy the sequence. So that's enough to get us started. Let's go to the second option, which is create the sheets. Now in this instance, we're going to do it differently. We're going to put one layout in each drawing. So you could make one drawing and put all the sheets into that. We're going to say, I want you to make an individual drawing for each of these sheets. And again, we click on the north arrow, and we go next. New sheet set, we should call this something else, webcast-multiple for multiple drawings. We'll press next again. Now, we're going to spend a bit more attention on the options here for the profiles. So instead of saying take all settings from the previous one, we're going to click on choose settings. We press the profile view wizard, and the first option we see here is the most useful one. It's called split profile view. So I'll tell you what that's for in a second. Let's just turn it on first of all. We then go to profile display options. So we're happy with those. For the bands, we could turn on more information, which we probably would do in reality. All I'm going to do here is tell it that profile 2 is my natural surface, which is good enough, and we press finish. Now it's going to do all kinds of XREFs and DREFs for us here, which we'll explain more in a second. Just all you have to know at this stage is that it's automatic. So you press create sheets. It tells you it's going to save your drawing. That's cool. I've renamed it, and we move these up here. So what it's now doing, if I bring back up my folder, it's creating a sheet set and a bunch of individual drawings in the same folder as my original. We could have browsed to a different folder if we wanted. Let's just leave it, go to its motions here. It's got a few to create. So you can see on the Windows Explorer view that the drawing files are now arriving. So you can open them from there or from the sheet set manager, which is also created, and it's called it webcast multiple, as we told it. So if I open one of these, actually, first of all, let me just explain the logic behind splitting the profile view. I'm sure many of you, or most of you, are already familiar with this. But if I draw a line across my profile view here and press F8 for ortho, you can see that as you travel along the length of this, that there's a huge change in elevation on specific sheets. So what you want to do to fit it into the A1 sheet is have splits along the view. The software, again, is clever enough to do that automatically. So let's just open a few of these. So we look at sheet number 2. So it's done the same thing as it had done previously. It's put in the correct north arrow orientation. It's got the surface in the background for us and the correct profile at that range. If we zoom in here, you can actually label the surface from here as well. So if I go to annotate, add labels for contours, click my surface. This is a reference view, but I can add labels to just this view as well. So you can put labels on the master view, or you actually have the functionality to put specific labels on the individual sheets as well, if that's relevant, because you may need to highlight something on just one sheet and not the rest of them. So that all works automatically. All you have to do is pick the object and look at the ribbon and pick the options you need. So if you go to one of the later sheets, which is at a totally different elevation range, you will see the software again has been clever enough to do all the correct adjustments for us. So again, I'm going through this very quickly because I want to make sure I get to the XREFs and DREFs. But the point I want to get across here is that when you import the 12D ASCII, you've got the objects in Civil, so you've done the hard work, and to actually take advantage of those by putting labels and sheets and all that kind of stuff is quite easy. So let's just close this drawing and jump back into PowerPoint for a second. The next thing we want to talk about is the actual workflows with XREFs and everything else for production. So let me just close these drawings first of all. Let my computer free up some space. So that's a super quick charge through the civil objects and the 12D import process. Let's just look at the standard kind of XREF production method. Now what I've got here is a simplified version of a drawing that I've seen nearly every office I've been to. You've got a kind of a base master drawing, which is being XREF'd into a bunch of plans, and that's how your drawings are produced. What has to happen here is you've got different contour intervals on different layers, so that in plan 1, if you're showing 1:500, and if you're showing contours at 1 meter intervals, you basically make specific layers visible and others not visible. Now, I know everyone watching this understands this better than I do, so I'm not going to show drawings. I'm just going to mention the fact, and I'm sure everyone understands the pain that goes with it already. Now, if you don't use annotative text, you also have to put text on different layers. And it's one of these awkward things that when you're making revisions to the drawing, you have to redo, and et cetera, et cetera. So that's just my impression of the XREF method. Now, more than happy to hear corrections on this. The other kind of consequence is that the drawing you're XREFing into each plan becomes quite large, because it has to contain multiple copies of all the contours at the various spacings. So the data shortcuts, which people call DREFs these days, they use the exact same philosophy. So we still have the base drawing with plan 1, 2, 3, 4. The difference here is that in the base drawing, which I'm showing up here on the top of the screen, the styles don't actually matter. So I've got my natural surface showing up here. I'm just illustrating it can be just the boundary only. There's actually no contours turned on. When you go and deref it into your plan drawing, so what we're illustrating here is the base drawing going into plan 1. You can tell it how to actually display the surface. So you can say, in this drawing, I want that surface to show at 1 meter contour intervals. And you can also tell it to just bring in that one surface. You can bring in everything if you want, or you can say just bring in the relevant piece of geometry only. So same thing applies. You can bring in the alignment and just show that geometry, and also you can not have to bring in all the other information that you didn't want initially. So let's jump into CAD and show this. So they've actually made the process quite simple. Let's look at the generic data shortcuts first. So it's been around for quite a few years, but on the newer releases, they've made this very, very accessible. So this is my base drawing here. So I put it on the top left of my screen. So you can see what I've got here is there's two surfaces with triangles showing. So you can see cyan triangles and gray triangles, and there's also a bit of horizontal geometry. So I've also got my plan drawing set up. So what I've got here is the same surface showing up, and it has got a couple of labels around the place. So the labels are actually pretty important, because that's going to show the process when we make a change. So I'll just zoom out quickly and zoom back in. So I'm trying not to make your screens lag too much behind. So let me just zoom back in to where the labels are at. So if you can read these labels, you see contour labels of 126, 125, etc., and some spot elevations. So let's go back into the base drawing, and let's click my gray triangulation up in that same corner where the labels are at. And what I'm going to do here is select Paste Surface. And what it's going to do is paste that platform onto the surface. So you can see the contours of this platform I've designed called Grading Group. So when I press OK, it's going to combine these triangulations. So you will see the gray triangulation has now updated. Now, I'm doing this as a quick way to show triangulation changing. How it changes doesn't matter, which we'll show in a second. So I press Save here. Now here's the important bit. In this drawing, which is showing the surface in a completely different way because it's showing contours, the standard XREF bubble appears. If you can read that on your screens, you'll see it says Data Shortcut Definition may have changed. When I press Synchronize, the contours update and the labels update with them. So what it means is that we've done a kind of a tidier version of XREFing where we've only brought in the one model we wanted. We didn't have to worry about showing different contour elevation ranges, and once the labels are put on once, they stay there throughout the update process. And it's also very easy to change these, so if you wanted to pick any one of these labels and move it around, just grab it and drop it where you want. So that's the derefs working. Now, if I go back to the prospector, if you look on the left, you'll see the data shortcuts set up here. So in this case, I've got the correct one open. So I press New Drawing. And let's just move this over here. And on my new drawing, I've got my EG and FG surface available from here. So if I right-click one of those and select Create Reference, before I create the reference, I must save my drawing. So I'll save this drawing here. I'll call it Plan 02. So I'll right-click on EG here and create a reference. Pretty simple. As that reference comes in, you can change some parameters, including style. So in that style here, I select, let's say, contours 5 meters. It shows up like this. So that's a totally different interval. And just to show the process working again, let's go back out to here. I'll do some butcher work and remove a chunk of geometry from the surface. So if I pick my gray triangulation on my base drawing, I'm going to select Edit Surface, and you will see an option here called Delete Line. Now again, it doesn't matter how you do this. I'm just picking the quickest method of doing it. So you can see I've created a big hole in my surface here. So again, I press Save, and when I open up my just created Plan 02 drawing, if your screens are quick enough, you should now see the data shortcut definition has changed again. So I press Synchronize, it goes and updates, and you can see the same hole has come out of these contours. So the concept is quite simple. It's just a very, very powerful way of doing things. The other useful fact, which is a very frequent question we get, is that on this Plan 02 drawing here, you can't do anything to the surface besides change the aesthetics. So I can label it. I can pick the surface, and I can select Add Labels, Contour Multiple. No worries. But when I pick it here, I don't have the options in the previous one for adding triangles or doing anything else. So it's just basically like an XREF. On my master drawing, you do have the option here of editing the surface, but not on the plan drawings. So it means that if you got some student working with you and you want to give them access to a drawing, you won't have to run the risk of them damaging the master drawing. So hopefully you got the deref concept here. We're running a bit tight on time, so I want to just jump back into PowerPoint very quickly. So that's derefs. Now, when you look at the overall process, when you incorporate 12D into this, what usually happens is that 12D gets put into that base drawing via DXF or DWG export, and the various XREFs get created from there. What we're doing in this case is we're making the exact same hierarchy where we've got the 12D and the base drawings and the plan drawings. All we're changing is that getting from 12D to the base drawing is done via a 12D ASCII export, and you use derefs in combination with XREFs if you want to form the plan drawings. So that just gives you more flexibility and more power. Now, when we show this to people, I think everyone grasps the concept pretty quickly, and the question they always ask is, what happens when the 12D design changes? How clever are these derefs for updates and everything else? So I've got a slide here to illustrate it. I'm just showing here, first of all, that the layers aren't necessary in the deref version. But the next PowerPoint here, this illustrates how the changes work. Now, I'll do it twice, because I want to make sure people get this. So what we're looking at here is 12D on the top left exports a file called design.12D ASCII, which is then processed through a system. If a change happens, what you do is you export a new file, or you overwrite the previous file. So you export design rev01.12D ASCII. You open that base drawing and basically update the geometry. And once you've done that, all the derefs work as you'd hope they would work. and the annotations and everything else that the drafting team has done is maintained on the actual source drawings. So that's the concept which we always draw on the whiteboards. This is a more tidy version of it on a PowerPoint. Let me just show it, and then we'll come back to this slide very quickly. So let's just jump into CAD again here. Now, this is probably the most important thing to take from this session. So let me just get it set up, and we'll work through it. So this is my base drawing. So let me just, now your screens are going to be lagging for a bit here because I'm going to move quite quickly to get things set up. Once it's done, I'll slow down and we'll go through it properly. So I've got my 12D ASCII, my base drawing, and I've got two plan drawings just to show some options. Now, I think I'll just use one of the plan drawings because we're very close to finishing up here. And then what we're going to do is make the updates and show what happens. So let me put that drawing across to the side. And what I'm going to do is resize my Civil window as well here. And I'm nearly set up. I'm going to put this across here. Now, on the far left of the screen, you can see a file called temproad.12da. So I've just highlighted it. That file has been imported into this drawing here on the left-hand side. So the file is called base imported from 12D, which has then been derefed into this file cross on the right-hand side. Now, on the file on the right, you can see some elevations of -6.6, -6.1, and -6.9. And you can also see that the red line, which I've just clicked, that's our design profile, and that's currently in cut. So an update has happened, and the 12D guy has exported a new file called temproad2.12da. So what I'm going to do is open up my base file here, and I'm going to re-import. So I go to my toolbox, import, and this is stuff you've seen already today, so I'll do it quite quickly. So I click on temproad2. So I'll just pause here so your screens can see this. I'll click on the second file just to show the update in the 12D. I press OK, and I'll right-click and click on Select All Models and Strings. So that just brings in the updated version of the same geometry with the same model names. So that's all good. I save that drawing. Now, when I go to my plan drawing here, I'm just going to maximize this within the screen to make sure you can all read everything. So let's just show a few different views here. So what's going to happen when I press the synchronize button is that the red profile on the right-hand side, that's going to move from cut into fill. And if you can make a note that the contour labels on the left-hand side are -7, -6.5, and -6. So I press the synchronize button now, and have I pressed that? Here we go. So it's spinning around. The contour labels are now -4 and -4.5, and you can see that the profile view has gone from cut into fill, and all the labels in the profile have updated as well. So let me just, I'll do it a second time because it's, as I say, the most important thing to understand. So on the PowerPoint, again, what we're showing here is the design has changed in 12D. We have exported a new file called Rev01 or Rev2 or whatever you want to call it. You open the base drawing and update the geometry, save it, and everything takes care of itself. And once again, I want to illustrate the fact that the labeling that you've done, that the drafting team has done, is maintained. So what I'll do is I'll just reverse the process just to make certain that people are happy with this. So again, let me just show, I'm going to go back to the original file called temproad, So to achieve that, I'm going to go to my base file, and I'm going to just re-import the geometry. So import 12D ASCII. I open. I'll go back to my original file. So I'll just pause here so your screens catch up with this. I'll select the temp road without the 2, which is the original file that we worked off. I'm going to right-click here and click on Select All Models and Strings, Import. And that's been imported successfully. I save this drawing. So all I do now is the exact same thing I had previously. So I'll just maximize this view so you can see everything. So once again, if you watch the contours, you will see that the values are minus 4.2, minus 4.4, etc. Sorry, that's the spot elevations. And the contours are minus 4 and minus 4.5. So I press the synchronize button, and the contours themselves will move, obviously, and the labels will move with them. So here we go. Now, there's a bunch of other variations on this, but we've just reached the end of our time. There's a nice example where we combine the 2 surfaces. I'll bring it up. If it opens up quickly, I'll show it to you. And then we'll just jump back into the PowerPoint for a wrap-up. So while this is coming up, I'll just jump into PowerPoint. So you've seen the way the derefs work. Now, the points, I've written these on for myself. It may be the case that only one of these is relevant. So if all you want to do is label contours and you're happy to use standard DXF exports for everything else, that's cool. We can work with that scenario. Or if it's just planned production or whatever it is. There's been quite a few people have asked me specific questions, and I've been telling them, look, watch the webcast, get an idea of the generic kind of a flow, and we'll come see you afterwards, and we'll work out what's relevant. So the other question is, where do you download this? So if you go to your subscription center, you will see the 12D extension for Civil 2011. So I've just got I've got a red box around it on the bottom. So if you can't get to this page, or if you need some help on it, email us, and we'll go through it with you. But there's a few other files here as well, including the Genio one, which is also quite useful. At the moment, we can import from 12D. We can't export to it. That's coming. I'm not exactly sure on the release date, but they just decided to release the first bit first, which in many ways is more relevant, I think. But you will be able to export things into 12D if you want as well. So most of the people on this list have got Civil already. So you can download this thing once you're on subs, which everyone is. So there's nothing stopping you having a crack off it straight away. And that's why we want the feedback, because it was written for us specifically. We made a song and dance routine about it, and they wrote it up to keep us quiet. So we want to make sure that we give them feedback and tell them what's relevant to make it more useful for us. So the questions in terms of what's in it for the various people, most 12D guys I speak to are happier doing designs than labeling contours. So they're very happy to stick with doing their designs and pass the 12D ASCII files out so that the drafting team can put the labels in and not bother them to change bits and pieces or to reproduce long sections or different vertical exaggerations. So basically, it enables the 12D guys to do real 12D work. For the CAD guy, you've got the extra flexibility of putting in the labels and annotations and everything else when you want to do them, and you're getting more exposure to the design process as well. And for management, it makes a lot of sense to have the 12D guys doing the design work and the drafting guys doing the drafting work. So from our point of view, it seems like a win-win solution, which is what we're so excited about. Now I want to just summarize it once more. So this is my last graphical PowerPoint. So we know that the design is normally done and it gets DXF'd to the drawing file. So the consequence of that is that lots of the drafting work is done by the 12D crew. Whereas if you use the 12D ASCII method, the drafting is done by the drafting crew. So again, this is what appeals to management, I think, because the correct groups are doing the correct tasks. And the important point to emphasize is that your design does not change at all. Sorry, your design procedure does not change. It's the exact same thing. All you do is select 12D ASCII instead of DXF. So that is, we'll go to questions in a second. I want to just emphasize the fact that we want feedback. You will get an email sent to you with a link to a survey. So please click on the survey. It's a very brief one, just a couple of questions and a space for comments. Put in your honest comments because we want to know about them. And we will work off that. So let me just quickly go to the questions panel, which I haven't been looking at all through the session. So I can see there's quite a few of them here. So what have we got? So in 12D, there's an option to show cumulative volumes in the long section. How do you do it in Civil? You can do it. You must sample across sections. I'll make a note of that, and we're happy to do a webcast on that very topic. But yes, it can be done. Sheetset Manager results should be 100%. Okay, we'll have to get more details on that. Again, we can take this feedback and put it back to Autodesk too. There's something missing. Does the importer read super alignments? Yes, it does. And we're pushing to get the exporter to write super alignments as well. Would you need a surface snapshot before erasing the triangles? Yeah, that's from Andrew. That's a good point. And we can ask the developers to automate that on the import process as well. So using the 12D import tool, how do you map strings to desired color and line type inside the white option upon import? Do you have to map each model to a layer individually? Demo, please. Okay, that's an interesting question. You basically map them to styles, and the styles can work with layers or they can have individual colors. So you can do either option. We'd like to know which one is more relevant. So can we change the 12D coordinate system when you import the contours inside in 12D? Well, and the labeling contours, and that when they make updates, they have to redo the updates over and over. So coordinates can be changed. Okay. So there's some nice comments here about good potential. They like the look of it. Does the import 12D drainage strings? Yes, it imports drainage strings and pipe strings. That's the last thing that got put into the software. So they come in as polylines, and you have to then convert them into pipes manually afterwards. So that definitely needs improvement. So it's something we're going to work on, and we're going to get basically as much feedback as we can, put it back to Autodesk and have them make some more information on it. What happens when a drawing with derefs is opened up in standard AutoCAD by someone who wants to make a quick change? Are all linkability features lost? No, the derefs, like in AutoCAD you can see them, but you can't do anything with them. So we'll do a webcast on linking AutoCAD into this process as well. So we'll basically get a few of us here in the office using different platforms, and we'll switch views to show exactly how it works. So why isn't the design just being done in Civil 3D? Well, basically because there's a bunch of 12D guys out there. Where can I get the templates? So all these templates are on the ANZ country kit, which we've got your email address here. We'll send you details about that. Is there an interface with Civil and PC Drain, PC Sewer? So the answer is no, as in not today. We've got somebody working on it in the office right now. So we're hoping to have something ready for testing in that very, very soon. Will this work on Civil 2010? The process would work, but the 12D importer is only for 2011 at the moment. So if there's enough guys needed on 2010, we can lobby to get that done. But we're currently more focused on getting them to enhance the functionality on the 2011 version. So does it read drainage? We've mentioned that already. If the design changes, it is easy to replace the design surface features in the base drawing for reading into other drawings. Yeah, I accept that. That's definitely correct. It's just there's preferences for which method you want to use and which functionality you need. Will it handle the cross-referencing of super alignments to other super alignments? I'll have to get more information on what that question means. So okay, I'll make a note of that when I come back to it. It looks like a 12D specific kind of question. So drainage lines again. Yeah, so Peter Thompson has just highlighted that AutoCAD interacts with the labels as long as you have the object enabler for Civil. So is there an option to export to Revit? No, at the moment. We can import a Revit view of some kind, but to export to Revit reads land XML to an extent, so that's coming along. So some more nice comments about the presentation, always good to hear. Last comment is Civil only needs to set up one individual label of each type. AutoCAD can copy them and respond to one object. Again, that's Peter. Yeah, so good comment, Peter. So look, we've gone slightly over time, but there's a lot more questions than we've had in previous webcasts, which is great. So thank you for your time. Please send the feedback, and we'll be very happy to continue on with more of these sessions. Cheers, and see you next time.